universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hello and welcome to SkyTour Radio here on KGRAradio.com. I'm your host, Mark D'Antonio. I think some of you know me by now. And I'm here with my wonderful co-host, Amanda Curran, and we have our other co-host, Daryl Mason, joining us as well. Hello, Amanda, and hello, Daryl. How are
Hello, Mark. Hello, Amanda. I'm good. You all doing okay?
I'm well, thanks, Daryl. How are you?
I'm good.
Good.
Fantastic. You know, I want to just say that, having Amanda and Daryl on the SkyTour Radio here is just one of those wonderful little gems that I just happened to cross with them. And boy, oh boy, I really like it because they ask some really good questions sometimes. Well, most of the time, actually. I'm the one that actually muddies the water by talking too much, it seems. But one of the things that I'd like you to do, all of you out there in KGRA listener land, the most wonderful audience on the planet, is subscribe to our companion stream on to SkyTour Radio, which is called SkyTour Livestream. And that's on YouTube. And what is SkyTour Livestream? It's a clear night journey into the wonders of the deep sky, all courtesy of a research-grade telescope here at our observatory in northwestern Connecticut. All right, now we'll be able to see stellar birthplaces known as stellar nurseries. And these are beautiful nebulae that glisten and shine with many stars sometimes, and they glow pink when photographed. An indication of the hydrogen gas that's in these nebulae. We'll see all that. We can see these glittering jewel boxes of stars that are in rich clusters, and those are just gorgeous. They literally look like glittering gems. And it's also a stream where you can be put in charge. If you want, you can tell us objects you'd like to see. And if they're up, then we'll check them out, because you also drive SkyTour Livestream. Now, we have plenty of things to say and plenty of things to talk about. It seems that with the universe this, abundantly populated by materials of all kinds and stars and planets and nebulae, we just don't run out of things to see. But if you want to see something in particular, you'll let us know, and we'll be happy to look for it for you. Now, our very active chat group is where you can ask all these questions, and that is right there on the side in the SkyTour Livestream channel on YouTube. And we will have answers for you. And most of the time, my co-host on SkyTour Radio, Amanda, is there as well, and she will take care of helping to process questions as well. She's very good at that. And she also has some great questions of her own. Daryl will also join us from time to time, and he is also an astronomer like me. And we are just really energized by the night sky, especially a beautiful night sky. So, that said, that's SkyTour Livestream on YouTube. Join if you can. Lastly, our online store at fxmodels.com or at the FX Models Planetary Replicas site on Facebook is a very cool place to purchase 3D printed moon craters and Martian craters, Pluto landscapes, and landscapes from asteroids and dwarf planets in our solar system. These come directly from NASA space probe data that we took from the curated data, and we have taken this to the next level. We've made these beautiful landscape plates. They're 4-inch by 4-inch, but we can do larger on request. And they're beautiful and make a stunning showpiece. And we will have coasters available too. We'll have a set of 5 4-inch by 4-inch coasters of moon craters, Martian craters, and Pluto landscapes. Right? It's just gorgeous. We now have a KGRA email, so you can email us if you have questions at skytourradio@kgraradio.com. So tonight on SkyTour Radio, what are we going to talk about? Well, we're going to talk about the populated universe. Well, what does that mean? Well, if I ask Amanda or Daryl what it means to them, then they might say something different than what I might say. But let's find out.
I would say it sounds like a good title for a book.
Well, I think that's because I wrote a book called The Populated Universe, and it deals with some of what we're going to talk about tonight. But what does a populated universe mean to you, Amanda?
Well, it sounds like there might be more than just us out there.
Isn't that the age-old question, right?
It
You know,
is.
it is. And, from a scientific point of view, I'd like to examine this tonight and examine just what are the chances. Now, I'm not going to take people through the Drake equation, which is Frank Drake created this equation a few decades ago that basically took a tally of all the things we know about potential planets out there and stars and tried to calculate the likelihood of life elsewhere. And it was a very pessimistic equation because it didn't have answers to questions like how many stars have planets and how many of those planets are in the habitable zone, that not too hot, not too cold location, which we'll also talk about tonight. So, and now these days, that Drake equation, instead of being a pessimistic response of just the one civilization like ours, or two or three, that Drake equation has been reworked with the new data that we have based on the number of planets we know we have seen out there. And the Drake equation now gives us a startlingly different picture of our universe. And we'll talk about that tonight. And I want to ask Daryl the same question. Daryl, what does a populated universe mean for you?
Mark, I'm still wondering what the nerds will drink from their crater coasters. It has to be something like Romulan ale, I think. What does it mean to me? I'm sorry. The populated universe. Well, we're not alone. I mean, I've seen people say that the universe seems like an awful waste if there aren't people in it. Things, animals, creatures, organisms, beings in it. Seems like an awful waste. I would like to see you talk sometime tonight about maybe the counterpoint to the Drake equation, and that's the Fermi paradox. Is, well, if there are aliens, where are they?
Yes.
Why haven't we seen them already?
And that's actually great. That's a good point. We can address that now even before we jump into this because the Fermi paradox, for those who don't know, is attributed to Enrico Fermi, but it wasn't Fermi that actually postulated this. It was more of a group consensus when Fermi was working with other notable scientists. The paradox basically says, if there's this much life in the universe as everybody seems to think, well, then where are they? As Daryl said too, where are they? Why haven't we seen them? And that I think comes down to several counter, I should say arguments for and against. Now, the arguments that are for a populated universe are many. There's many, many planets. In fact, more planets than stars in the universe. There's many planets in the habitable zone of their star, which we'll talk about. And we have seen here on Earth that life finds a way to exist. Those of you who know me know that I really like the movie Jurassic Park. That's about the only one, the first of the series. And when Jeff Goldblum, as the rather pessimistic scientist, said, when they suggested that life it was not going to be able to reproduce from the genetics that was in these dinosaur eggs, Goldblum said, well, life finds a way. Life finds a way. So he was actually being cautionary, actually. And it turns out that life does find a way. We've seen life in the hottest, most inhospitable places here on our own planet. About the only place we haven't found life is inside lava flows. But guess what? Clinging to the walls around lava flows that have, like in areas where there's active lava lakes, there is life, bacterial life. Now, if it gets splashed by the lava, it'll die, but it then soon takes up residence again. And there's a number of these 2 or 3 lava lakes on the planet. So life exists in the most inhospitable places, whether it's the hot geysers or near lava flows. And so we've even found microbes on the outside of the International Space Station. Now, that's a vacuum. That is to say, very little atmosphere. I can't say it's a perfect vacuum because there is a little bit of atmosphere at the level that the ISS is, which is around 252 miles or so. It's molecules, but still, it's not zero. It's not just a full hard vacuum, as we call it. So, in the case of the aliens being here, the case for them being in the universe, I think that if you look at the vastness of the universe, it's understandable why they may or may not have been here, and because we can make an argument that says, well, they would have been here already, and then moved on. Now, when I talk about the history of the Earth, we see that there's been a huge chain of events that took place over 4.6 billion years. And the universe existed for over 9 billion years before any of that ever occurred. So any races or species out there that did find an advanced mechanism for travel could have approached and arrived at the Earth billions of years ago when we were just pond scum. All right? Or maybe they could have shown up in the Cambrian era or the Permian Ordovician, Silurian. They could have been in the Devonian era. They could have arrived at any point in our history. Now, there are people that say, and I don't disagree, that they're here now. Maybe that's true. Maybe when they arrived millions of years ago, perhaps, maybe they never left. You know, so it's possible that they're here. And if you think about it, there could be kind of like in Star Trek, a federation, which, and I'm not saying that's what's happening. I'm saying that it's a possibility that they would think along the same lines, that they don't want to interfere with us. And I mentioned this, I think, in the last show. You know, I talked to someone in Facebook on a Facebook post, and they said that we're like ants on a sidewalk to aliens. And my response was, actually, we're not. We're actually considered a fairly complex species. You know, we are not diminutive in stature. We are not diminutive mentally, because we actually have advanced. We're actually fairly well advanced, in spite of the fact that we're not interstellar and that we can't get along with all of each other on the planet yet. Okay, so we're not necessarily a species that is an ant to an alien species. Okay.
May I add?
Yeah.
Some people think we're still pond scum.
Well, that's very true. But I'll say this: any species in the universe worth its salt is not going to view the human race as pond scum or even at that level, because pond scum can't kill you. All right. And human beings certainly can. You know, human beings are a force to be reckoned with. We are actually a species that needs to be treated with caution. Just go up to someone's house unannounced and knock on the windows at midnight and see what you get for a response.
Heck yeah.
Right? That's yeah. And so you see, we are a wary species. We're wary. If we weren't, we wouldn't have locks. We wouldn't even have invented them. We would have just had everything open. You know, so you know when we talk about the Fermi paradox, saying, well, if there's life elsewhere, where are they? Well, if there is life elsewhere, they may not want to make themselves known to us if they're visiting us. That's the other counterpoint to that, is they could have actually been here and done things surreptitiously. And guess what? That's exactly what's been reported. People have been reported being abducted on an individual basis and taken away and you know, experimented on. I mean, that's pretty heavy duty stuff. You know, some people have had their lives ruined by this. So is everyone having psychological breaks? Is everyone hallucinating? Is everyone doing you know, these drugs that make them, you know, see things? I think not. I think we're talking about a real phenomenon. You know, and I've always felt that was a real phenomenon. Bud Hopkins studied this for many years, and Peter Robbins, my very good friend Peter Robbins, he will tell you all about Bud Hopkins because he was one of Bud's very close friends. In fact, I sat there in rapt attention as Peter talks about, Bud Hopkins and talks about everything that Bud did. He has a beautiful presentation on Bud Hopkins, and we'll see Peter actually at the Pine Bush UFO Festival in just another week and a half. So I think that the point being that aliens, if they're here, they are sufficiently advanced that they can hide from us, but they're not so advanced that we can't hurt them. See, if we couldn't hurt them, they would walk around among us with impunity. They just say, well, they can't hurt me, and they'll just bing, 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 we'll shoot at them and things will bounce off or whatever. But clearly that's not the case. So my feeling is they're here, but they're hiding from us. I was on a nuclear sub as a guest. I think I told many people this recently, and there was a very brief encounter with a very fast-moving object that was seen on the sonar that was moving several hundred knots. All right, now, nothing we had at the time, and still to this day, can go that fast underwater. Nothing that any nation has can do that speed underwater. But this clearly was. So what was that? As an anomaly? Well, they didn't think it was an anomaly with the system because it was outside of the sub for sure, and it wasn't something that was that repeated. It was there and it was gone. We never saw it again. Now that could make it maybe a machine anomaly, maybe, but I don't believe so, and neither did anybody else on that boat. Just so you know. So are they here? Well, they could be, and I think that they would be hiding from us. All you have to do is look in our oceans and look on our land and say, where are the beings that populate this planet? Well, they're not in that water. Oh, well, let's go hide there. If you can go interstellar, you can certainly go under the water. If you have the means to avoid catastrophic failure of your ship going interstellar, then you have the means to protect your ship when you want to go underwater. So I think that they could be underwater. Now, it's funny. We always say, science fiction has often become science fact. And that's true. Excuse me. But when we see science fiction like the movie The Abyss, aliens in the bottom of the Mariana Trench, okay? When we see things like that, I find that fascinating because to me, it's sort of plausible. That's where I'd go. Either that or I'd set up on the moon. But then we know if you're an alien race looking at the humans from the moon, that the humans, the Chinese and other, Japanese, they have probes as well as the Americans that circle the moon at only 60 miles up and are taking imagery of the moon all the time. So rather than have to even worry about that, they could do far better and have less travel time, okay, if they simply were to hang out near our ocean floor where humans never really go. We go there once in a while, but that's it. So I think that the answer to the Fermi paradox is that they may very well be here already and just watching us from a distance. And for what purpose? Well, there's one thing that every creature on this planet is imbued with. Every creature, by the way, every single creature of more than I should say advanced multicellular type creatures. They all seem to have this one characteristic called curiosity. Curiosity is something that the living things on this planet have. Why do dogs run up to something and sniff it? Why do they look at something in the distance and say, what's that? They don't say that. But I mean, dogs approach. Now, people have explanations for the behaviors of creatures and what they do. But there's something to this. And all creatures express some type of interest in other things. And so that's something that we have. Every creature on this planet has that interest. And I'll use that term more than curiosity. But So I think that that's something that a visiting species would be wary of, and make sure they don't want to come under our microscope and be on our radar. And so they'll probably go someplace where they can't be found, and that's in our deep ocean, where we can't even look down there with a same device we use to catch things in our atmosphere, which is radar. Well, we can't use that underwater. We only have sonar.
Don't you think they'd be curious enough that if they were here long enough, they'd want to interact with us?
I think that's true, but then you have to figure out who and which population on the planet you're going to interact with. And it's probably my guess, it's a long-standing scientific mission that they're on. Long-standing mission. And the mission is to simply monitor. Maybe there's probes that come here and drop off biological robots. I've often thought that the gray aliens that we so often see are biological robots. But then there's other people that say, well, no, they're not. There's some that weren't indifferent. There were some that were actually, paying attention and telepathically communicating with me. Well, if that's true, then it's possible that they're not the robots and they look different sometimes than these little grays. So maybe the ones that look different are the visitors, the true visitors, and the biological robots are the grays. Now, I don't know any of this for sure. It's all speculation, but it's all about discussions of the populated universe. Now, Daryl, I just want to make sure that, did you have any more to say on the Fermi paradox? Did you want to offer something?
No, the only thing that comes to mind offhand is remember the Vulcans showed zero interest in us until they saw a warp signature come from Earth.
That's true. That's right.
Yeah.
Yeah. And in Star Trek, obviously, we're not trying to, and neither is Daryl, we're not confusing reality with science fiction here. But
didn't I hear somebody say science fiction becomes science a little while ago?
Yeah.
Science fact, yeah.
Yeah, I seem to recall that being said by one of the three of us.
Well, and that's, see, I'm still having a hard time reconciling this.
Okay.
Because the first half of the conversation, there are so many exoplanets out there, so many, sun-like stars out there. It's too big to say we're the only ones, and maybe a little naive, but then we start talking about grays and bionic robots and people coming, or creatures coming to visit and hiding out on the planet, and that to me it may as well be Star Trek. To me, it still sounds so far-fetched, but yet the science, I'm just having a really hard time reconciling this because I guess I'm a skeptic. I don't want to say I'm not a believer because I don't know, right?
No, that's good. That's good. I'm not a. I believe they're here insofar as I haven't seen evidence against it. I'm only seeing evidence for it, almost everywhere we look, and I can maybe help you with that skepticism or that problem you have, because remember we talked on some Skyter radio shows a few times. We've mentioned how Stephen Hawking said that hey, don't announce our presence. We really don't want to announce our presence to alien life, and he's talking about sending out a radio signal, sending out a record on a Voyager spacecraft showing where we live and all that. I thought that was those are benign things, because the chances of those actually being intercepted and found are very, very low. But the fact that we are here on this planet and existing under an oxygen blanket, basically an oxygen atmosphere, that's the biggest giveaway that there's life here. And if you are at all curious species with interstellar capability, you're probably going to look for other beings like yourself, carbon-based possibly. And if you're carbon-based, you're going to utilize oxygen because carbon-based life will do that. All right. Now, for the most part. So the question becomes one of, well, if you're going to be out there looking for life, how are you going to find it? Well, you're going to look for the planet that has oxygen. We're doing that. The James Webb Telescope hasn't even gone up yet, and we're going to be using it to infer from methane and carbon dioxide signatures in a planet's atmosphere that there's oxygen there and that there might be therefore be life. We're going to get that through inference, and we're only 5,000 years into our written history if you go back to Sumeria. And so we already know this. So a species that's been here for 1,000 years longer than us, or 1,000,000 years longer than us, is going to have the ability to look for a planet that has oxygen, and they're going to make a beeline for it because they're going to want to check it out if they're a curious species. And like I said, every creature on this planet has some level of curiosity built in. It's built in. We didn't create that. It's not just a characteristic of the human species. It's a characteristic of all animals, So, and I think the curiosity, for instance, is naturally selected as a success mechanism. Because if you're curious and you go check out something you haven't seen before, you might find an advantage, to your life. And so that's something that is very important, I think. So I think that it's important that we look at the fact that most life forms out there, if they're advanced, they're going to find us. They're going to know we're here. But they're going to be very careful about approaching us. Now, we can be excused for not being able to see them arrive because we can't even see asteroids in our own solar system that are, we see them usually after they've winged by us. That one was over. That one was about 1.5 times the distance of the moon. Where was it? Well, it's already past us. We didn't see it. Wait a minute, what? And some have come even closer, a lot closer, and we haven't seen them until they've passed. So you see, we're still in our infancy when we're looking at the universe, but the fact of the matter is we're getting better. And when we come back, we're going to get into this. We're going to get into some of the things that we're doing to get better. All right. I'm Mark D'Antonio with Amanda and Daryl, and this is SkyTour Radio on KGRA. We'll be right back.
Join me, George Norrie, in Indian Wells, California, for the 7th Annual Contact in the Desert UFO Conference, May 31st to June 3rd. Contact in the Desert is an epic weekend of adventure filled with exciting explorations into ancient aliens, human origins, crop circles, UFO sightings, disclosure, and the newest evidence of ongoing contact. This amazing weekend offers over 50 lectures, 40 workshops, 8 exciting panels, special events, and a luncheon that I'm hosting. Contact in the Desert also features leading experts including Giorgio Tsoukalos, David Wilcock, Linda Moulton Howe, Michael Tellinger, Eric von Daniken, Doc Wallach, and many more important researchers and scientists in the field. Contact in the Desert is your place for inside information. Join us at thecontactinthedesert.com to get your tickets today. It's time to make contact. That's contactinthedesert.com. Don't miss it. Contactinthedesert.com.
Balance of Nature's fruit and veggie capsules contain 100% vine-ripened fruits and vegetables, tested pure with no pesticides, fillers, or additives of any kind, and are the most effective whole food supplements on the market today. You might ask, how can over 10 servings of 31 different fruits and vegetables fit into 6 vegetarian capsules? Fruits and vegetables are on an average 85% water. Balance of Nature uses cold vacuum technology to remove the water, leaving only the whole food. We don't use any heat, air, or light drying methods that damage nutrients. Our cold vacuum technology maintains 99% of the fresh fruits and vegetables' original nutritional value. Along with diet and exercise, Mother Nature provides fruits and vegetables to help us maintain good health.
To order, go to balanceofnature.com or call 1-800-246-8751. That's 1-800-246-8751 and use discount code TALK.
Food was different 60 years ago. It was minimally processed, free of pesticides. It was nourishing and healthful for your body. Today, GMOs, pesticides, herbicides, and heavy processing have depleted the nutrition of our food supply, which takes a toll on our health and energy. It's harder than ever to get the right nutrition. That's what Life Change Tea is meant to counteract. Our specially blended, powerful herbal formulas can give you more energy without caffeine. It's a mild cleanse, a mild daily detox. A good detox can help revive and bring back the energy of your youth. GetTheTea.com is the website. It'll cleanse you from the inside out with this herbal proprietary formula. Go to GetTheTea.com. There's no fillers, no GMOs. It's organic. Not available in stores. You must go to their website, GetTheTea.com. And their supplements are a great way to maintain your health. Read the testimonials on the website. Go to GetTheTea.com. That's GetTheTea.com.
UFO TV All Access presents an original film, The Cosmic Matrix, Science, SETI, and UFOs. The movie that delivers real disclosure. Case closed. UFO TV All Access is available on UFOTV.com, Roku, Apple TV, Fire TV, Comcast, and download the UFO TV app from iTunes and Google Play. Alien disclosure has happened. Now stay informed. Go to UFOTV.com and subscribe now and see the new movie, The Cosmic Matrix. See the movie and join the revolution.
You listen to us, and we listen to you. And so does the CIA. KGRARadio.com.
Hey there, welcome back to SkyTour Radio. I'm Mark D'Antonio with Amanda and Daryl tonight. And tonight we're talking about the populated universe and what it means to us and what it means to me as an astronomer, for instance. How do we know it's a populated universe? And what does that mean, a populated universe? Well, there's other life. That's what it means. Everyone knows, well, of course there's other life. But guess what? We can't really know that for sure, can we? We don't even know if there's other life in our solar system. We strongly suspect there is. Okay, based on how life is so tenacious here on this planet and shows up in the most unlikely habitats. But still, we don't know if there's life elsewhere. I tend to think there is, and that's it's a rather optimistic opinion, but I do believe that there is life out there. The statistics are on our side as well, based on the number of planets we think we've found. But the question is, why do we even look for these planets? What are we looking for? Well, we're looking for another Earth, aren't we? For one thing, but we're also trying to answer that age-old question, which you all know. Is there life beyond the Earth? And I believe that there is life beyond the Earth, okay? And for us, we focus on searching for life that's based on the carbon atom. And we've talked about the carbon atom in previous shows, and we're going to talk about it a little bit differently today. Because if we were looking for an Earth-like world, we would want to know, why would other life even look like us? And there are people that say that you could only have carbon-based life out there. Now, does that make them carbon chauvinists or carbon bigots? And the answer is, well, yeah, but the fact is, everything on this planet is based on carbon. Carbon is one of the most prevalent elements in the universe. And we have found that all life here on Earth, and without any exclusion, is based on carbon. And the universe actually provides a template for carbon-based life. The building blocks of life are complex hydrocarbons and amino acids based in carbon. And they're delivered to the Earth via comets, meteors, and asteroids. And then the Earth makes these building blocks as well. And we'll talk a little bit about that. When we talk about comets, well, we didn't really know anything about comets other than the spectrum that we could see when we disassemble the light that comes in from a comet. We could figure out what's on it. And we found there are some complex materials on a carbon, based in carbon on the comet, on all the comets. And one in particular has that's in my mind is the one from the Rosetta mission. It's called Churyumov-Gerasimenko, comet 67P. And that's a comet that looked kind of like a kidney bean. Okay, it had a narrow waist and two lobes. And it looks like, more than half of that comet is actually made up of organic materials, and organic molecules. More than half. And that's pretty amazing. That's pretty extensive too. And the Rosetta mission was an amazing success. The only thing that didn't work on the Rosetta mission was the lander that was meant to go down to the comet, then shoot little prongs into the comet to hold itself to the comet, because it was so small, the comet that is, that it didn't have enough gravity for the lander to just land on without bouncing off. So it was going to have to snag the comet and stick to it with these little, like pitons from a climber. And so that didn't work. And the Philae lander, Philae, the Philae lander bounced off and bounced several times in the weak gravity and ended up lodged in the crevasse. And then it was found, by the way, in a camera. They could actually see it in the crevasse, stuck on its side. So as the comet evaporates, eventually the Philae lander will be freed. But by that point, most likely the lander will no longer be functional. The batteries will no longer be chargeable. But hey, that's pretty cool. But again, more than half of that comet is made up of organic molecules. That's really important stuff. So now, when it comes to meteorites, there's a meteorite that fell here on Earth, and it brought with it 90 amino acids that were lodged inside of it. These are amino acids that weren't contamination from the Earth. These were brought from other places. And I know Daryl on the last SkyTour Radio, he mentioned how he's wondering about panspermia. And what's panspermia? Well, panspermia is the notion that life was delivered to our planet. You see, Daryl? So the Murchison meteorite kind of supports your postulate, doesn't it?
Yeah, I've always kind of leaned toward panspermia. I mean, you mentioned that the Rosetta comet is over 50% organics, and we find amino acids everywhere. All the building blocks are out there, and it just takes a trigger. And is what's the hand behind the trigger? I don't mean to get off on a tangent, but
that's okay.
Yeah, I rather believe in panspermia as an idea. I mean, the building blocks are everywhere, and it just takes something to set them in motion.
Now, and then now I got to direct a question to Amanda, because she was saying before that she has kind of a tough time trying to put it all together. Well, how does this notion hit you with panspermia, Amanda? Now, thinking that life could be delivered here from extraterrestrial nature, like these amino acids being brought here. Now, amino acids aren't life, but they're the fundamental building block. So how do you feel about panspermia?
Well, that's what I was wondering. I guess it was on our last episode where you were talking about asteroids bringing water to the planet. And I was asking, why does an asteroid have to bring water? Like, would Earth not have had hydrogen and oxygen molecules anyway? And like Daryl was saying, they just needed a trigger rather than it being the asteroid. Like, wouldn't they have eventually fused together to make water? Like that's the problem. I'm like, I understand elements come from space and asteroids is a good way of getting here, but just for the planet to have developed as it did with all of the pieces of, I don't know, space junk to smush together.
Yeah.
Wouldn't we eventually have the gravity or the pressure or a trigger or something to have formed it ourselves here anyway?
Yes, that's all true.
So do we need panspermia then? Wouldn't we just need time? Like, wouldn't the formation of Earth have provided all the material we needed to begin with, which started at the beginning? Do you know what I mean?
Question. I do, and I remember it from the last episode when you asked, and here's what I say to that. My response to that is that everything that you mentioned is also a possibility. There is a possibility that panspermia occurred. There is a possibility that and we know that the Earth also created a lot of the molecules itself for life here on Earth, including water. We know that asteroids delivered water to our planet. We know that comets also delivered water to our planet. Apparently not as much as asteroids. That's the current thinking these days. Well, anyway, that said, what I'm getting at is, if you look at that, what's it telling you? It's telling you that the universe is supplying potential for life from a variety of different avenues. The Earth itself can make the building blocks of life. They're delivered by meteorites. Comets deliver them. Asteroids deliver them. We make water. Asteroids deliver water. Comets deliver water. So you see what's
I'd like
going
an
on?
asteroid to deliver something we don't have yet on Earth. Something from a really distant star whose elements just haven't reached us yet.
Well,
And then what would happen if a new element is exposed to Earth? Will that cause mutations in animals, in vegetation,
depends.
depending on what kind of element it is?
Yes, you're absolutely right. If it's a radioactive element, it can cause something. But, we know actually that there is, we talked about this on last Sky Tour Radio. There's a star out there. In fact, you're the one that brought this story to my attention. And kudos to you, and all credit goes to you. There is
the one from the other galaxy we may have absorbed, yeah.
Yes, there's a star here that we found, one star so far, that doesn't have the chemical composition of any of the stars around it, and it has more europium, okay, which is a element in the periodic table, has more europium than any other star we've ever seen in our own galaxy. And this is bringing up the idea that perhaps that star is an interloper. It's from a dwarf galaxy that we may have absorbed somewhere along the way. See, we came along 4.6 billion years ago. And maybe somewhere in the previous 9.3 billion years, or 9.4 billion years that had already passed, our Milky Way galaxy had collided with a dwarf galaxy that might have been in our local group of galaxies, which include the Andromeda Galaxy, Triangulum, and the two Magellanic Clouds, which are each these little dwarf galaxies. Maybe there was a third dwarf galaxy, and maybe what we're seeing as Magellanic Clouds are the results, or maybe they're the after. Maybe they're the after crash. They're the post collision results that came through our galaxy. We don't know, but where there's one star with this excess europium, there's more. So the hunt is on, and we're going to see if we can figure out why this one star has more of this one element than any other star so far seen in our galaxy.
So do that.
Yeah, I mean, so that's kind of interesting to me, and naturally, when we talk about the building blocks of life, if a meteorite delivers something we haven't ever seen before, clearly it's going to get everybody's attention. Now, it doesn't mean that we wouldn't have theorized the possibility of its existence before, because in digging through the periodic table and understanding how elements are made, we don't expect that we'll just see like an element 232, be delivered to the planet, but we do know that there are plenty of isotopes out there, some of which don't naturally occur or may not naturally occur as far as we know, that could be delivered for all we know. There's also ions, that is, atoms that have had their electrons removed from them because of the energy that's attacked the atom. That ionization causes these electrons to jump off. And when they recombine with the atom, they go through transition states. They come back down into the atom and go to different energy levels within the atom. When that happens, some of those transitions can't happen here on Earth. They can only happen in the rarefied area where there's not many atoms, where it's out in the middle of a nebula cloud, for instance. One such thing is doubly ionized oxygen, which is the O3. Okay, I've said it before. Doubly ionized is O3, not O2, as you would think. And then that 3 is in Roman numeral 3, and the 2 is a Roman numeral 2. Singly ionized is O2, O Roman numeral 2, oxygen, Roman numeral 2. And the base state of an atom is Roman numeral 1. So that's why it's one off like that. So the base state where it has all its electrons is oxygen, Roman numeral 1, oxygen 1. All right, so but those transitions are basically don't happen on the Earth. So, the question is, do we understand everything about the periodic table and the chemistry that made it in the stars? Well, no, because we didn't know that merging neutron stars would also contribute to making things like gold. Now we do. So we're still learning, and there's still things out there we don't know. So to your point, it's possible that there's other things going on in the universe that are going to surprise us as well. The universe is always full of surprises. Besides always trying to kill us, it's always full of surprises. And when we talk about these building blocks being delivered to this planet, you mentioned how the Earth makes them, asteroids deliver them. It's true. Now, in the way of the Earth, let's talk about that. The way the Earth makes these building blocks is a very interesting thing, because this is, in part, why we're here. Now, when Stanley Miller and Harold Urey in 1952 created this experiment, they didn't know if they were going to get a result that was going to be astonishing or just, lackluster. Well, it turned out that their experiment, which was designed to see if the early primordial atmosphere, as we understood it, could produce the building blocks of life, was a unbelievable and unmitigated success. What they had was a round glass ball, and in that round glass ball they had water, methane, ammonia, a molecule of hydrogen, H2, 2 hydrogen atoms, and carbon monoxide. These are things that we thought were in the early primordial atmosphere. And they also had what's called a spark gap in there, 2 little electrodes. And these were hit with a charge every now and then, which would make a spark across the gap between the electrodes inside the same chamber with this primordial atmosphere. At the same time, in that same chamber, water was introduced as water vapor. All right. And they simulated the water cycle that happens on Earth, where water's evaporated from a reservoir by having another ball nearby and glass tubes that connected to this big tube with the primordial atmosphere in it. And they sent water into it that way through, heating the water, having it evaporate, and then the water vapor would come down in this spark chamber with the methane and the ammonia and the hydrogen 2 and the carbon monoxide. And they just let this thing spark away, and let it go for a week. All right. And it turned out that, this setup was amazing, because the setup actually produced amino acids. And, it produced a number of amino acids. And this was interesting. They were coating the bottom of that big flask where the spark gap was. So amino acids, we know, is the building blocks of life. And it came to be known as the Miller-Urey, that's Urey for Urey. The Miller-Urey experiment actually was a fundamental experiment to show how the Earth itself creates the building blocks of life just because of lightning, which is a natural consequence of a planet with an atmosphere. Now, when Stanley Miller died in 2007, the funny thing was, those original sealed vials were re-examined, and they showed that more than 20 amino acids had been created that were undetected originally. So there was a lot going on, in there. Now, I just like to make this statement too. When we look at the life on Earth that resulted from these building blocks of life, it's weird because we all have the DNA, deoxyribonucleic acid, and ribonucleic acid, RNA. I mean, they're like, those are templates, for making other similar structures in the body, all right, and in the organism. And they give rise to a really strange property that every single life form on this planet shares. And I think I mentioned it a couple of times, and maybe you might remember, Amanda. What's the property that we all share that is really interesting? It's how we interact with our environment, but it's not how we're built internally. Do you know what I'm talking about?
Oh my God.
I know, right? That's crazy. Daryl, how about
Ask that again.
Okay.
No, I was gonna say carbon, but then you really threw me. How
No,
we
no,
interact with each other?
no. Actually, I probably asked the question a little too convoluted. There's a property that all creatures on this planet have that is it's the same for all creatures, and
they can replicate.
That's actually very important, right? They do have the ability. That's actually part of the definition of life, is replication. That's true. But I didn't want to get to another property, and I won't tie you guys up with this because you may not know where I was going. But it's called bilateral symmetry. Across the center, was that you?
That's not where I was going.
Oh, okay.
Well, when you were saying a property we all share, I was like, carbon. We're all carbon based.
That's also very.
And then you started talking about communications and stuff, and then I was like, oh, I don't think it's going to be carbon.
Yeah, no, I didn't give you probably a good enough question. My apologies. No,
bilateral symmetry. Okay.
Yeah, across our midsection, we could draw a line through the middle of your head, straight down to your body, or straight down to the ground. Everything to the left is the same as everything on the right. Okay, it's a bilateral symmetric being that we are, and it turns out that all higher life forms show this. They have bilateral symmetry. Now there are some different creatures also that have radial symmetry as well, and we'll talk about that for a bit. But the internal arrangement may differ in these creatures, but the way the creature interacts with its environment, the way that it's naturally selected by evolution and by the carbon-based structures that the body is made of, the way that it interacts with the environment is through a symmetric architecture. So this bilateral symmetry, though, is not all we see. Think about flowers. That's a radial symmetry, right? And along a radius out from the center, and flowers and starfish, which are known as echinoderms, or echinodermata. And, echinoderms are interesting because these are starfish, but starfish have 5 arms, don't they? Okay, 5 little arms on them, and these starfish are what are called pentameral. They're 5-sided, but when they're larvae, when they're first born, they're bilaterally symmetric at first. And I'm not saying all life is. That's certainly not. Okay, but starfish are, and it's kind of weird. They are bilaterally symmetric when they're born, and they become pentameral as they get older. It's kind of interesting. So that's sort of an oddity on the planet, that every creature has this bilateral symmetry to me. And I think that the most important thing is that these things all came about through a template that the universe provided, and that template was based on water, carbon, right? And actually, it's based on several different elements, and those elements are carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur, and that spells chomps, CHONPS, chomps. And if you remember that's those are the magic elements that are very important. And carbon is a good one because, as I mentioned in another Sky Through Radio before, carbon, the element carbon, has the ability to bond and create more compounds than any other, and more bonds and more compounds than any other element in the periodic table. It is truly a master element. Okay, truly a master element. So it stands to reason that it would actually end up becoming the most flexible element there is. And it is. The carbon is the one. So I don't think we're bigots to look for carbon life. I think that carbon-based life is probably going to be considered the norm rather than the exception among the life that we find out there. That's just my feeling.
Mark?
Yes.
Help me out here.
Sure.
I suspect you would say that if we met life from other stars, it would also be bilaterally symmetric. Would you agree with that, or not necessarily so? And where does the bilateral symmetry come from?
I think that's a good question. The bilateral symmetry, in my view, I think, comes from our most primitive architecture. It comes from the fact that we have a double helix in our DNA, which strips off to become a single strand, which is then duplicated. See, symmetric. So the symmetry goes right down to the DNA. For instance, when the DNA is split and you have this RNA, the RNA goes into these locations in the cell where it's duplicated, right? And that duplication is completing the symmetry. So I think at the tiniest, smallest level, we are a symmetric species. We are a symmetrically built species. So I believe it's an offshoot of that. I can't make the connection mentally right now to all the different aspects of it, but I do feel that it's something that is based on our most primitive construction. See what I mean?
Oh, I agree. But, what about being some other planets? What if they really did show up and they had 6 legs or 8 or something, or, not necessarily bilaterally symmetric, but radially symmetric, maybe in the case of the 6-legged critter?
Yeah, but they have an even number of legs, though. You're making it even. I don't know if that's going to be fine.
Okay, I hear
Starfish only had 5 legs.
It does. It has 5 arms. That's correct. And that pentamerism is something that is, we see that throughout nature, actually, with plants, too. Plants are radially symmetric. Some have 4 petals, some have 6, some have 26, some have 24, some have 44. I mean, there's a lot of different creatures out there that show this radial symmetry, but the symmetry is all based on something, as Daryl was saying, and I think that it's based on that right down to our DNA and how DNA replicates. The splitting off of the helix and then the rebuilding of the other side to form that's like a message. That's the messenger RNA. So I think that's a very important aspect to it. And aliens, I don't know. I think aliens could very well, show up looking a little different. But I think if it's carbon-based, and I think if they have a DNA of their own, then that symmetry is going to be built into them too. And on this planet, every single creature shows this. Every single creature has, every advanced creature has more than, has 2 eyes. We have spiders that have, 8 eyes. Okay, we have creatures that have photo cells in addition. And we have other things that other properties of creatures that are different than what humans have, but are nevertheless symmetric. And I think that's something that is going to probably be a template in the universe. That's my feeling. And when we get back, we're going to talk more about what this whole, what Earth-like actually means for life as we know it. And then when we talk about life as we don't know it. But we'll be right back. Stay tuned. This is Mark D'Antonio with Amanda and with Daryl on SkyTour Radio. Talk to you soon.
UFO TV All Access presents UFO Secrecy and the Death of the Republic, a movie that delivers a fresh analysis on the black budget breakaway civilization, the weaponization of space technologies, and the global UFO cover-up under the Obama and Trump administrations. UFO TV All Access is available on UFOTV.com, Roku, Apple TV, Fire TV, and Comcast, and download the UFO TV app from iTunes and Google Play. Go to UFOTV.com and subscribe now and see the movie UFO Secrecy and the Death of the Republic.
Balance of Nature's fruit and veggie capsules contain 100% fine-ripened fruits and vegetables, tested pure with no pesticides, fillers, or additives of any kind, and are the most effective whole food supplements on the market today. You might ask, how can over 10 servings of 31 different fruits and vegetables fit into 6 vegetarian capsules? Fruits and vegetables are on an average 85% water. Balance of Nature uses cold vacuum technology to remove the water, leaving only the whole food. We don't use any heat, air, or light drying methods that damage nutrients. Our cold vacuum technology maintains 99% of the fresh fruits and vegetables' original nutritional value. Along with diet and exercise, Mother Nature provides fruits and vegetables to help us maintain good health.
To order, go to balanceofnature.com or call 1-800-246-8751. That's 1-800-246-8751 and use discount code TALK.
You know, food was different 60 years ago. It was minimally processed, free of pesticides. It was nourishing and healthful for your body. Today, GMOs, pesticides, herbicides, and heavy processing have depleted the nutrition of our food supply, which takes a toll on our health and energy. It's harder than ever to get the right nutrition. That's what Life Change Tea is meant to counteract. Our specially blended, powerful herbal formulas can give you more energy without caffeine. It's a mild cleanse, a mild daily detox. A good detox can help revive and bring back the energy of your youth. GetTheTea.com is the website. It'll cleanse you from the inside out with this herbal proprietary formula. Go to GetTheTea.com. There's no fillers, no GMOs. It's organic. Not available in stores. You must go to their website, GetTheTea.com. And their supplements are a great way to maintain your health. Read the testimonials on the website. Go to GetTheTea.com. That's GetTheTea.com.
UFO TV All Access presents an original film, The Cosmic Matrix. Science, SETI, and UFOs. The movie that delivers real disclosure. Case closed. UFO TV All Access is available on UFOTV.com, Roku, Apple TV, Fire TV, Comcast, and download the UFO TV app from iTunes and Google Play. Alien disclosure has happened. Now stay informed. Go to UFOTV.com and subscribe now and see the new movie, The Cosmic Matrix. See the movie and join the revolution.
You listen to us, and we listen to you. And so does the CIA. KGRARadio.com.
Hey there, welcome back to Sky Tour Radio. This is Mark D'Antonio with Amanda and with Daryl. And we're talking about the populated universe tonight, and now we're moving to what the concept of Earth-like means for life as we know it. Now, Daryl mentioned earlier in the last segment, like, what about, he didn't say it this way, but what about life as we don't know it? Could life show up looking differently or acting differently, not having the same symmetry that our bodies have and that all creatures on this planet have? I guess that's possible. But based, in my view, I'm thinking that, and maybe that makes me one of these carbon bigots I was saying I'm not. But maybe if they are based on carbon like we are, then, and they have DNA, then it's possible that they will also have this symmetry built into their architecture as well. But and I think that, we don't see any, and I used this term before, we don't see any pogo stick cows hopping around in a field, because there's no naturally selected creature that could survive with that trait, apparently. Maybe it did happen. Maybe there was one. Maybe there was a creature that actually did have some type of different architecture, but it wasn't a success. I don't know. We don't know. We haven't seen it.
Arthur C. Clarke actually wrote about such a species a long time ago. They were monopods, pogo sticks, but they acted like kangaroos in his story. Yeah. I think that's where I got the pogo stick cow concept, actually. Huh. Yeah, because I talk about pogo stick cows, because everybody knows cows and everybody knows, they're black and white, and just seeing them hopping around on one big giant leg, doing, doing, doing is kind of funny. But, I think that's you have to slow cook that sucker.
Not necessarily. You could leave it in peace.
Oh, see that, Daryl?
Yeah.
There with Amanda now.
I'm bad. I'm sorry.
Don't eat meat.
I don't eat meat, actually. I don't like it. It doesn't. Well, my body doesn't like it. Let's put it that way. So, but cows and food that we eat, they are all Earth-like creatures, right? And what does Earth-like mean? Well, it means that on a planet that can support life, it means the planet was going to have liquid water on its surface for life like us. And for that, it has to be in what's known as the habitable zone of the star. And the habitable zone of the star is a really interesting concept because You just say, well, the Goldilocks zone, the not too hot, not too cold location
Right.
around a star. That's what everybody says. But there's a lot more to it than that, and I won't bore you with all the details. But it has to do with the atmosphere as well. There has to be a substantial atmosphere that can support liquid water at the surface, and that's all part of being in the habitable zone. If you don't have a planet that's warm enough, then you won't be able to support liquid water. It'll be frozen if it's too cold, or it'll boil away if it's too hot, like Venus. Okay, Venus had a lot of water vapor in its atmosphere, still has some, but it's destroyed quicker than it can be processed by the planet into something else because it's too hot at Venus. There's no room for any movement at Venus in terms of the evolution of the planet. It's too close to the sun by just enough so that you can't get that atmosphere to thin out by, for instance, maintaining a water vapor atmosphere that can then rain out on the surface as water. It's too hot.
What if it got hit by an asteroid that had a bunch of ice?
Well, that's an interesting concept. What would happen to Venus, I wonder? We should go into some simulators that we have and try to actually create that and see what we would get. It would have to be substantial. But actually, I think that the best way to do it would be to hit Venus with smaller asteroids that are loaded with water content to see just how the planet would transform. One big one would turn the planet molten, and the water would be boiled away and destroyed. We'd have to hit it with smaller ones that the planet could absorb. See what I mean?
Yeah.
I think it's pretty cool, though. It's a great thought you had. So I'm going to try that, actually.
That's a terraforming idea. That's been around in science fiction for a long time. And I've heard it postulated if we were going to terraform Venus, we would do it from the atmosphere and maybe be living up in big cloud cities, floating up high up in the atmosphere above the acid and everything. And they've said the same thing about Mars, too, about, bombarding it with comets or asteroids to bring more water to the planet.
Yeah, except that Mars has enough water as it is. It's just that it's all trapped underground. So how do we get it out of there? And that's the concept that Amanda's really fond of, and that's by the way we can actually do this is we can actually terraform Mars without ever going to Mars, without even touching Mars. We can create a magnetic sheath that surrounds Mars on the leeward side, the downwind side, this down solar wind side of Mars, and create a magnetic field that's in the Lagrange point, which is that parking spot in space between Mars and the sun, which is much nearer to Mars. And so we would create a magnetic field there, and in the solar wind, when it strikes the magnetic field, it causes it to drape around Mars, and now Mars would be protected by a pseudo-magnetic field that we generated. Now, if that happens, then when the natural processes which bring water into the Martian atmosphere, which do occur, all right, those water molecules now, before any protections in place, will be what's called photodissociated. They will be ripped apart. Those are H2O molecules. That's, H2, that's two hydrogens, and an oxygen. Those will get ripped apart by strong ultraviolet radiation from the sun. Why? Well, because Mars doesn't have a magnetic field to capture the strong solar wind, and it doesn't have a substantial atmosphere to deflect a lot of the ultraviolet radiation. So how do we build up an atmosphere? How do we allow the water vapor to build up in the atmosphere? Well, we do it by actually giving Mars a magnetic field it doesn't have. The magnetic field, as you guys know, and as many of the listeners know, is created by the planet's core. On Earth, it's the solid iron nickel core that we have, and the molten outer core moving against the inner core that causes giant electric fields. And these electric fields, in turn, generate a magnetic field, which is what we call our magnetosphere. And they that magnetic field traps these high energy particles from the sun, these high energy protons that are streaming toward us from the sun, and it traps them. And they are trapped in these magnetic fields, and these are what people call the Van Allen radiation belts. See, and around Mars there's no radiation belts because it doesn't have a magnetic field to trap particles. If we could give it one, there's a mission on the docket at NASA to actually provide and terraform Mars in this way. Now we would notice a change on the Martian surface literally in only a few years. We would easily detect the increase in water molecules in the atmosphere, and sparse as that atmosphere is, adding water molecules to the atmosphere by the umpteen trillions would actually cause the atmosphere to become denser. You'd be getting more clouds. Clouds in turn will trap heat and will cause the planet to heat up. What will that do? That'll melt groundwater once the pressure builds up and the atmosphere builds up more. And then once we get above that 6 millibar pressure, which is where it is now, we will be able to have potentially liquid water on the surface of Mars. And then once that happens, we will end up seeing a water cycle naturally begin, where water will evaporate, go up, form clouds, and maybe even rain. And once we get to that point, then our little blanket, as Amanda likes to call it, that's protecting Mars, will be doing its job. And now Mars might be ready for colonists, to go there. Now, right now, when we go to Mars, we'd actually have to treat it as if we're landing on like the moon, right? It's not a hard vacuum, but it's what we call a soft vacuum. It's actually very close to a hard vacuum. At 6 millibars, it's not the 1,000 millibars. And millibar is the pressure on the planet's surface. We have 1,000 plus, just over 1,000 millibars here at sea level on Earth. And at Mars, we have 6 millibars. So you can see that it's really quite a lot less atmosphere at Mars. So Mars is just on the outside edge of the habitable zone for the star, our sun, and Venus is just on the inside of the, just outside the inside edge of the habitable zone here. And of course, Venus is too hot and Mars is too cold. Kind of like Goldilocks and the Three Bears. You have too hot, too cold, and just right. And Earth, of course, was just right. Now, the habitable zone of the Earth and where it is around the sun, the habitable zone is actually not narrow. It's actually fairly wide. It extends almost to Mars and extends almost to Venus. So in a variety of ways, if the Earth was just a little bit further out, then the planet would be a little bit colder and a little closer. And of course, the opposite would be true. So we happen to luck out right now because we evolved in an atmosphere like this. We evolved with an atmosphere of 1,000 millibars or so, and we evolved in an atmosphere with an average temperature that we have now on the planet. And had the planet been a little bit closer to the sun, then we would still be able to evolve, but we would just be different. We'd be slightly different. And if it was a little farther away, we'd be slightly different. Not as far as Mars, but we'd still be able to work and live and survive. So the other thing that you need besides this habitable zone and liquid water is you need a star that's stable. Now, you've heard of X-class flares, right? Daryl, you've heard of X-class flares, right?
Oh, yeah.
Yeah. And many times these flares will shoot particles toward the Earth, sometimes in these big mass ejections that come off the sun. And if they strike the Earth, then what happens is they can take down electrical grids. That's happened. That's actually happened where we've lost our electrical grid.
What are you calling them?
Those are coronal mass ejections and solar flares.
I've heard of solar flares, but you called them something else.
Yeah, coronal. Yeah, there were mass ejections. Coronal mass ejections. Corona. The outer atmosphere of the sun, and then particles and material, plasma, shooting off the sun coming here, highly charged. When it gets here, it's going to enter the magnetic field and spiral around the North Pole and the South Pole. And depending on its energy and its intensity, we might end up seeing that really, far south. I've seen auroras here in Connecticut right over my head. So bright, it was amazing. And it was because of a coronal mass ejection, and it was just incredible. We had beautiful greenish blue auroras all night long. And then by 3 a.m, it was a dome of pink that went horizon to horizon. A pink dome. It was like living under a dome, kind of like in that Star Trek episode, For the World is Hollow, and I Have Touched the Sky, where the sky was that pink. Incredible stuff. Anyway, so our sun is a fairly stable star, considering. And as Amanda is fond of reciting, we have the spectral types of the stars, spectral classes. And our star is a type G, right? And the G-type stars can be stable. And we don't really find planets in stars that are very, very hot, because they tend to be short-lived, that is the stars, and not enough time for the evolution of a planet to occur and possibly bring out life, as far as we know. And Amanda, you remember the spectral classes?
I hopefully I'll remember it forever.
And it is?
OB and FGKM.
Wait, what?
OBAFGKM.
That's correct. And you said that rather fast. You didn't have to use the metaphor that I shared with you. That's great.
Well, it's a pattern, because, the first few letters are the same. OBA.
Yeah.
Is the same, even if I'm saying OBA, fine guy, kiss me.
Mm-hmm.
So.
Yep.
OB and FGKM. I still say it with the pattern as if I'm saying the words, but hey, it's still working, so.
That's right. That's fair enough.
Hey, if it works, stick with it, right? Why change it?
That's correct. Mm-hmm. And those O stars are very hot, and they don't live more than 10 to at most 100 million years. And then there's the B stars next, as she said, and those B stars are also very hot. But they're not as hot as the O's, and they're not as big as the O's typically. When you're big, you burn through your material, twice as fast. And that's why these O stars don't live long. That's why the B stars are a little longer lived, but they also end in supernovae generally and release their contents back to the interstellar medium. We call it the ISM, the interstellar medium. And so that's a problem, because for life to exist, it has to have a very delicate balance of long stability and a long-lived star. And for that to occur, you have to wait until you get to the spectral class of A-type stars or so. So not O's, not B's, but A. So A-type stars, lower temperature, longer lived, more stable. All right, and then you have the F-type stars, all right, a little bit heading toward the yellow. And then you have the G-type stars like our sun, and then the K's, as Amanda said, and then the M's. The M's are the interesting little birdies of the universe, and I'll tell you why. The M stars, there's more of them in all of the galaxies, in all the entire universe, than any other stellar type. Okay, more M stars. They're the most populous star in this populated universe, I think. But none of them you can see with your eye. They're so faint. They're all very small. They're like little tiny percolators. They're the universe's coffee makers. They sit there and perk away, fusing hydrogen into helium for trillions of years, as opposed to billions of years like our sun will do. Our sun can go billions of years, about 10. But, an M star can go trillions of years, because they're so small, sometimes only about the size of Jupiter. We actually found a star smaller than Jupiter, believe it or not. It was just a lot denser and could begin stellar fusion to create hydrogen or helium from hydrogen. And that's something that was a new thing we found. We discussed it here on Skytour Radio. Well, anyway, the thing about stable star systems is that M-type stars are actually not as stable as the other types of stars. Now, their O's and the B's, of course, they're not even being included in this question because they only live a few tens of millions of years and then they explode into supernovae. Okay, that's one hell of a destructive force to ruin your day if you're living on a planet around there, but there's probably no planets there. The stellar winds from these stars are very, very powerful, and they're just dosed with huge amounts of ultraviolet radiation. In fact, most of the radiation of some of these stars is in the ultraviolet realm. So that's incredible. And the light is way too bright as well. So, and think about that. More light coming out in the ultraviolet that you can't see. So you wouldn't last for very, very long, split seconds perhaps, around an O star, the same distance of the sun from the Earth. So star systems being stable is a very important thing, and M stars, not quite as stable, but there's more of them, so the chances are greater. And because they're so small, the planets they have around them, of which there are many, they tend to be what's called tidally locked. The planets are so close to the star that the same face of the planet will face the star every time. You know, and I'm really fascinated by these tidally locked planets. I got to tell you, you know, both Amanda and Daryl, and of course our KGRA listeners, I'm actually fascinated by tidally locked planets because I really think that this would be a great thing for like real estate agents. If you want to see sunset, you want to do a sunset cruise, oh man, you're in luck. You know, you just go there and you don't have to wait for the sunset. It's happening all the time. If you want to do tropical beach visits, well, tropical beach, man, that's 24/7, tropical beach, you know. And if you want to do the stellar, exploration and put up an observatory and look at the night sky, wow, on a tidally locked planet, you don't have to worry about the planet rotating out from under the stars. However, the one thing you do have to worry about is that the planet is going to be circling the star very quickly. Now, it takes us 365 days to go around our star. That's our year. Well, some of these planets go around their star in some cases a few hours, and in many cases a period of days, between 6 days and 12 days, perhaps. Now, that's the planet's year. So instead of following the stars, like because of the rotating planet, you're going to use a telescope that follows the stars based on the fact that the planet is moving around the star so fast. So that means that when we look at a possible planetary system around an M star, we're going to be looking for tidally locked planets. And this means necessarily that the life forms there are going to be very different. They're going to be brought up, if they evolve at all, they will come about with maybe a resistance to ultraviolet light, which would work for them here. But for their star, maybe because these M stars have ultraviolet flares more often than other stars, perhaps the ultraviolet flares would be something they could resist and be part of their structure if they have DNA to resist DNA tampering by the ultraviolet light. And that's something that would be interesting to find out too. Now, also, if they're from the Terminator side, where the sun is always setting, or from the starlit side, let's say they evolved over there, how would they communicate? Would they use light, to communicate? Would they use sonar to communicate? Would they yell in the darkness? I mean, maybe. But how would they see? Well, to see, would they develop some type of night vision, biological night vision? Or would they be very colorful, photoluminescent, like these bioluminescent beings? That's possible too. Maybe
I was thinking that when you were saying some planets go around their star like within hours.
Yeah.
And because you were talking about, different tourist spots and real estate and stuff.
I know.
If you were in a spot where you were looking at the sky, like doing astronomy like you guys do, looking through a telescope, how would you even be able to focus? to see things going by if you were moving that fast.
Well,
what kind of sight would you have then?
Yeah, well, that's true. Well, let's say as life forms on that planet, how would you focus? Well, our Earth is rotating, and we've often turned off the drive in Sky Through a live stream, our companion stream to Sky Through Radio, and we've seen the stars moving. You're watching the Earth rotate out from under the stars. The Earth is spinning on its axis, and we actually watch that rotation. Well, similarly, we would have the same thing going on. We would have the stars doing the same thing, but just at different rates, depending on which planet you're on. If you're going around the star in just a few hours, well, then these stars are going to be zipping through the sky pretty fast.
That's what I'm thinking, and I guess we would compensate, but it's just weird to think how we would compensate with the, I don't know.
Well, every
as Mark,
device.
Yeah, as Mark said, it's not really focus, Amanda. It's tracking. That I'm sure if anybody was sufficiently technologically inclined on a red dwarf planet to build a telescope, they could probably figure out the motions in their sky, such as we have here on our planet, and try to come up with an equivalent sort of a tracking mount, so you could keep it in the field of view of the telescope.
Yeah, it would be natural for them to do that. They wouldn't know any different, just like we don't.
Right.
We just assume our planet's rotating. Okay, let's compensate for it, and we did. But yeah, I think that I think the issue is one for philosophers. Okay, because the bottom line is that we don't even know if there's such beings in existence out there. But I'm sure we can talk about more of them in the next segment coming up. But we'll talk about that when we get back. And when we come back, we're going to talk about a few other types of stars, too, and how they support life. And then we're going to talk about how all those building blocks even got here in the first place. All right? And we'll do that when we get back here on Sky Tour Radio and KGRAradio.com. We'll see you soon.
Okay, nurse, let's get this man to the ER stat.
Right away, doctor.
We see this every day. Heart attack or angina pain due to blocked and clogged arteries. Chelation can remove obstructions or blockages from arteries and help avoid painful and expensive surgery. Now there's Angioprim. It's a liquid oral chelation product that you take with juice. You start to feel the results fast. Angioprim increases blood flow all over the body, and that means more energy and strength to take on the day with less aches and pains. 60 years of research has gone into chelation, and Angioprim is the result. A safe and easy way to unblock your veins and arteries from buildup that slow circulation.
Paging Dr. Jones. Please report to the emergency room right away.
Log on now for a special radio offer from Angioprim. That's angioprim.com/radio. ANGIOPRIM. Angioprim.com/radio or call 877-882-7221. That's 877-882-7221.
Hi, it's AJ from Vibes, Mind, Body, Spirit. Have you been searching for unique items to create or add to your sacred space? What about tools for your holistic healing? Or those one-of-a-kind magical ingredients to manifest your desires? Well, look no more, because Vibes has a variety of items to assist you in your spiritual journey. From crystals to candles, incense to books, tapestries to jewelry, OnlineVibes.com has what you're seeking. We even have some thoughtful and mindful gifts to share with your friends and family too. Visit us at OnlineVibes.com from the comfort of your home, or give us a call at 385-244-1099 to have your order beautifully packaged and sent directly to you or a loved one. And right now, take advantage of the coupon code KGRA at checkout to receive 15% off any order. Remember, online, VIBEC.com.
Now there's a commercial-free, video-on-demand TV channel completely devoted to only the best movies on UFOs, ancient mysteries, conspiracies, and suppressed science. It's called UFO TV All Access. UFO TV All Access is now available on Roku, Amazon Fire, Apple TV, Chromecast, UFOTV.com, and download the UFO TV app from Google Play and iTunes. Go to UFOTV.com and subscribe now. That's UFO TV All Access. If it's not UFO TV, it's just a hoax.
Now you have the inside contact for alternative talk radio. The Planet. KGRAradio.com.
Hey, welcome back to Sky Tour Radio. This is Mark D'Antonio, and Amanda is with me, as is Daryl. And we are all sitting here in awe of our wonderful universe, and we want to talk about just a few things that go along hand in hand with the habitable zone, the liquid water, and the stable star. And that is, can all these stars support planets and life out there that we see? And we talked about just a little bit of that before. We mentioned how the O-type stars, which are those big blue hot ones that last only 10 to 100 million years at most, those stars just can't do it. They're too hot. They have too powerful radiations, and they would not be able to support a planet. A planet, in fact, couldn't even form, most likely. Similarly, with the B-type stars, they couldn't either. So, we're looking at A-type stars on down. And when we notice that from A through M, the A, F, G, K, M type stars, that actually represents an awful lot of stars, actually. And, because O stars are relatively rare and B-type stars are somewhat rare. But, the A's, the F's, the G's, the K's, and the M's, they're in order of abundance after that, actually. So the M's are the most abundant. And it seems that these are interesting stars, those M-type stars. They could have the most number of planets. We know they have the most planets of any other type of star in the entire universe. All right. So the question is, how do planets even get to form at all? Well, first you have to have the raw materials, don't you? And the raw materials are, well, everything in the periodic table that we've seen so far. And the periodic table is a really fascinating table. And if you go back to chemistry, you'll think, I just want to get out of here, take me home, get me out of this classroom. Well, you know what? It can be fun in a way, because when you see it at the high end, then you can understand it a little better. The elements in the periodic table come from processes within stars, as you know. The primordial elements that were available were very simple. It was hydrogen and helium and a little bit of lithium and beryllium. And beyond that, the other materials were made in the hearts of stars. And that whole fusion process we've gone through before, so I won't go through it again. But, the elements form in a variety of ways. And some are formed by the collisions of one element into another like element, and they form a new element. So two hydrogens can be crunched together under high pressures and high temperatures to make helium. And then the helium can can be smashed together to form other elements beyond it. You can make carbon, you can make nitrogen, oxygen, fluorine, neon. And you know what? I can sing the entire periodic table. I can, every single element. And I won't do it. Maybe if someone pays me enough, I'll do it. But I'm not going to do it tonight. But I can do it. And it's actually kind of...
June.
Huh?
My birthday's in June.
Oh, man. I may have to do it. At Pine Bush, when I do my talk, I may have to sing the periodic table.
Ooh.
Ay. I can just imagine that. Well, for those of you out there that haven't heard it before, it starts off with there's hydrogen and helium and lithium, beryllium, boron, carbon everywhere, and nitrogen all through the air. And it goes on and on. Okay, I can do the whole thing. I ain't going to do it. Okay, I'm really tempted, but I won't do it. Anyway.
Show the fun side of astronomy.
Oh, it is.
Oh, come on, Daryl.
What did you say?
I said, I don't remember how I said it. Carry on.
Thank you.
Oh, yeah, I for one, thank you. I've heard it before.
Yes. Yeah.
I have too, but I like being serenaded, and eventually I'll learn it too, not to sing it, but just to know the periodic table.
Now, hey, all of you listening to this, if you want Amanda to learn how to sing the periodic table, send me an email or get in touch with KJRA and say, we want Amanda to sing the periodic table. And we will force her to do it just for you. Oh, Amanda's quiet now.
Well, it was good up until the word force. Then my back went up a little bit, but no, I think it would be a good idea for me to learn anyway.
No, it's a fun thing. We'll make you learn it because it's important. How's that?
Okay.
All right. Anyway, these elements are amazing to a lot of people because they say, well, how could they show up? How could they be formed? We know that in these higher mass stars, that elements all the way up to iron, which is number 26, all right, elements up to iron can be manufactured in the hearts of stars. Okay, but beyond that, all the rest come from different processes. You want cobalt, number 27. How about copper, number 29? Right, germanium, 32. Okay, selenium, 34. Where's that come from? Krypton, 36. Where do you get that? Rubidium, 37. I mean, where do all these come from? You know, so tungsten, 74. I mean, the thing is, these elements are created in a variety of ways, and yes, supernovae can create a few of those past iron in the supernova process. However, many of these elements, believe it or not, are created literally in stars like the sun. Well, you'll say, wait, I didn't think the sun was massive enough to create anything way up at iron. And it's not. It's not. The sun can only produce at most carbon. At most. And maybe not even that. But it'll probably make some carbon over time. Now, so how can it ever end up making like platinum or silver? Okay. Well, it can. And that process is something that has to do with how under pressure and under high temperatures that the elements themselves, which are made of protons in the nucleus and electrons circling the nucleus. Okay. You want to know how that happens. Well, basically, if you have a carbon atom, all right, or let's just say a carbon nucleus, you're going to have 6 protons in the carbon nucleus. Well, guess what? Because of other processes in the sun and in other stars, you can actually, for instance, have neutrons, which have no charge, get thrown in and forced into the nucleus of these atoms. And when you add neutrons to, say, carbon atom, that makes it still a carbon atom, but it's a different flavor of a carbon atom. It's called an isotope. All right. So it's still carbon, but it has extra, basically mass, extra weight, basically in the center of that nucleus, and those are the neutrons. They don't add charge, but they add mass. So, interestingly enough, over time, sometimes neutrons can become spontaneously changed into protons. So let's say you got a carbon atom that has an extra neutron in it, and that neutron gets changed into a proton. Well, now it's no longer a carbon atom because a carbon atom has 6 protons. It's a nitrogen atom with 7 protons. See? So this is a process that takes place in stars about like the size of our sun, and it's called the S process. It's called neutron capture, and it's where neutrons become protons, and in the process they create an electron plus another high energy particle that comes off as well. And these are the way that the other elements are made. Typically, It's supernovae, and it's this S process, this slow process where the neutron is captured and made into a proton. But then we also have another thing that we've saw just in recent years. We've seen collisions between neutron stars, didn't we? We saw merging neutron stars. Remember that? And there was one particular element that we've kind of wondered where it came from. And it turns out, yes, that's right.
Yay! I remember that.
Amanda said gold.
Yeah.
And it's true. When the neutron stars merge, it seems like that merger is where a lot of the gold we've found in the universe comes from. How about that?
Can you give a layman's explanation for that, please? I know neutron stars merging and such are the new hotness now. And I remember when they said shortly after the neutron star merger a year ago that, golly, that's where we think gold comes from now. Well, why?
Well, I mean, again, it's a process that's now there's an S process and there's another one called the R process. S means slow, R means rapid. Okay, so I'm guessing that it's probably a rapid process that has to do with that instant merger, and the pressures and the temperatures are so high that additional neutrons in the nucleus of atoms, making the isotopes, can be converted very quickly, perhaps, to protons, and that might force other atoms. Now, it might not be just gold; it might also be, platinum. It might also be mercury, which are the neighbors in the table. So it's possible, and even iridium, maybe, I don't know, and osmium. But there's a lot of this process going on, the fast process and the slow process. So I imagine that that's probably where that's coming from. We have, there's probably no less than 30 elements in the periodic table that are created in this way from merging neutron stars. It's not just gold. It's just gold happens to be one of the more common ones created this way, as is iridium and platinum. Okay, those are others that are very common, and I think that so in other words, I think that this process is the one that's doing it, and I can actually, I'm not a nuclear physicist guy. I'm just an astronomer, a lowly astronomer, but I would actually be happy to look into that further to give you another answer on the next show, because I'm sure that that's something that's
well, I guess what I'm wondering is the gold and all the precious metals, is that coming from inside the neutron star, or is it being created in the immediate outside of the neutron star? I would think that it was being made inside the neutron star. Well, it should stay inside the neutron star.
But it won't, because when in the merger, okay, there's this. Remember, we saw the merger, right? We actually saw the merger. It was actually a massive explosion too.
Okay.
Remember, they were disrupted.
All right. Well, maybe that's the key word then, disrupted. I was not aware of that. I think you'd take two neutron stars and put them together. You get one bigger neutron star or a black hole.
Well, yeah, you would, because the neutron star can only be like 3 solar masses,
right,
individually maxed, and actually this thing is 2.2 or 2.3 solar masses, and you go higher than that, and it wants to become a black hole, but it's a violent event. And keep in mind that the surface of a neutron star is as hard as a billiard ball, and that's the thing that is hard for people to follow and understand. And being that's as hard as a billiard ball, then when this merger occurs, we're actually that surface is being fractured, and that fracturing is going to release a ton of energy, and it's going to cause an awful lot of processes to happen all at once. And so when that happens, and we see this disruption, and we get like a kilonova. Not just a supernova. It's even a higher power explosion, and that's something I think that is going to make the difference in terms of how we get to see this gold here. You know what I mean?
Yeah.
Yeah.
Yeah, I mean, I'm visualizing here, and it seems like you take two neutron stars and stick them together, they're really going to stick together, and form one bigger neutron star, if not a black hole. But when you say hard as a billiard ball, I assume you mean actually it's harder than diamond. I mean, it's like really ultra hard.
Yeah, it sure is. And remember, we're talking about, and see, on the surface of a neutron star, unlike a white dwarf is what our sun will become. And that's when our sun's core collapses down to its final size. After it goes through a red giant phase, it collapses down. What's left inside becomes a white dwarf. And there's mostly carbon and oxygen atoms on the surface of that white dwarf. And they're compact, but they're in a state of what's called degenerate matter. Okay, it's matter that is crushed together under such powerful force that, in the white dwarf's case, it's the electrons that are pushed together so hard that they occupy every space in the atom they can occupy, and so they basically, you can't push any more in, and that acts like a pressure pushing out. You can't push any more in, so therefore it's sort of like a wall to further compression. But you make it more massive, and it can be overcome, and then you end up with the neutrons, and that's the neutron degeneracy, the neutron degenerate matter, and that is a spot, again, that magic spot where beyond a certain amount of mass, the neutrons can hold up the pressure of and withstand further collapse from gravity of the neutrons, of the star, the remnant. And then just a little bit above that threshold, which I think is like 2.2 or 2.3 solar masses, then that neutron star cannot hold itself up against further collapse, and that's when it becomes a black hole. But when two neutron stars merge, we get this kilonova, this explosion, and usually you have these really rapidly moving neutron stars circling each other, and because of all the drag and the other issues of say, or these orbiting objects that are radiating so much radiation, they will actually end up spiraling closer together. And when they spiral close enough and they do finally merge and strike each other, then they're both disrupted in that massive event. And it's during that time that we get these additional elements. Like I said, there's about 30 or so, let me see, about 25 elements, I think, actually, that are produced in this manner, including xenon and tellurium and indium. I mean, it goes on. There's a lot of them, not just gold, but that is, again, gold is one of the major produced elements, along with platinum and osmium and
do we know what has to be merged to make the higher elements that haven't been accounted for yet, that we can't replicate here on Earth?
Well, actually, we do know that in such mergers, plutonium is almost exclusively created by merging neutron stars. So that's an example, okay? And europium, gadolinium, terbium,
so like everything we know on the periodic table,
yeah, I mean,
is created in stars or from merging stars, or
yes, to everything.
Okay.
Yeah, it's created in the hearts of stars from normal processes, from supernovae, from merging neutron stars. Okay. In fact, merging neutron stars are responsible for elements from 62 to 94, almost all. Okay. It's not responsible for every single one of those, but literally the vast majority, though, from 62 to 94, and it's also responsible for some of 72 to 80 in the periodic table, actually 83, and from 44 to 54. I mean, we're talking about a huge number of elements.
How long has this been current theory? Excuse me. How long has this been current theory? Because I don't remember ever hearing of gold, for instance, or anything else being formed by merging neutron stars before the first LIGO event last year.
That's correct. And I think that that is when the thinking was changed. Remember, astronomy is a moving target. We're only as good as our technology that we have. And when the LIGO detectors detected the emerging neutron stars and they detected the gravitational waves, they also saw that when they trained their telescopes, they saw that obviously there was a kilonova going on, and that kilonova is where we learned about the fact that these elements were being created. And so
all this has just come about in the last year then?
I believe that the things like the S process has already been known. The R process already known.
Yes.
Supernovae already known. But the emerging neutron stars, you only heard about gold because gold was the thing that, obviously, hey, everybody wants gold, right? So they picked on gold. But the fact was that, I could tell you all the elements that are created in emerging neutron star based on what we've learned here from this event. And this is only this one event, actually, that showed this to us, But yeah, this is new stuff. And so the science is I don't know, it's a learning process for us all, right?
Sure.
Yeah.
Well, yeah, Amanda and I talked about this a little bit before yesterday's show, that, if this is just one example of what neutron star mergers, black hole neutron star mergers, or, black hole mergers, is teaching us or making us form theories about anyway, scientific theories that, golly, what else is down the road? Ultimately, this is why we're doing what we're doing.
Daryl's right, folks.
He usually is.
Daryl's right. No, he's got a great point. Daryl's literally now walking headlong into the same wall that I walked into when I decided I wanted to become an astronomer. I mean, this was something that I wondered too. I wondered where all the elements in the periodic table came from. I know that people said, well, for the longest time, it was supernovae that did all the rest.
Right.
And undoubtedly, there's some of that. Yes. Okay. Some of that will be true. But, the other thing too is gold is also produced in the dying low mass stars too, in this S process. Did you know that?
I did not.
Yeah, this slow process. Gold is produced there too. So is platinum, and so is iridium. I mean, so are these elements. But the majority of this material, though, does come from these merging neutron stars. You have to remember there's overlap everywhere we look, though. There's typically overlap. Okay, there's very few elements that are created solely in one way. Let's see, lanthanum. Okay, that's a dying low mass star. Niobium, dying low mass star. Barium, dying low mass star. No, barium also has merging neutron stars too. Okay, so basically, there's only I don't think there's any one element that's actually produced in only one manner. You can find them through exploding massive stars, supernovae. You can find them through merging neutron stars, dying low mass stars. These processes are all, crazy, but the three big processes are the normal fusion process that creates up to iron for the higher mass stars, the supernovae, which then usually from the higher mass stars that produce a few more of these elements, and then the S process, which creates these other elements that we mentioned in a slower way. And then we have the merging neutron stars. I said 3, and I'm going to give you 5. We have the merging neutron stars, okay? And then we have the R process, which is a rapid process which occurs during supernovae and kilonovae as well. So there's a lot of ways in which everything that makes us who we are was manufactured out there in the universe. Now, I don't know if that leaves you, Amanda, with either a bunch of confusion or a bunch of questions. But either way, I'm sure we can address it. We have about 3.5 minutes left.
I think I'm following it. That's what I was kind of getting at. Like, you said, like, one process brings you up to iron. The next process is, the next little set.
Yes.
And then it brings you up to the top. The rapid process brings you to the top of the elements that we know of. What else haven't we seen?
Well, we haven't seen what happens when white dwarfs explode. I mean, white dwarfs are like stars like the sun. When they end their lives, they become these little quiescent white dwarfs.
But that process has happened before, and
yes,
we haven't gotten any new elements because of it. Like,
actually, we have.
We have? Ooh.
Yeah, I mean, they're not new elements, but elements that you may not have realized come from this process, for instance. So, for instance, when we look at like white dwarfs many times will be in binary star systems. So you might have a red giant and a white dwarf. Well, the white dwarf is a certain mass, and they tend to all be about the same. But if they get any more mass on their surfaces from basically getting material on them from the nearby star, well, then they can actually explode in a nova. And when that happens, they also generate elements. They cadmium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, and copper and zinc are elements, for instance, that an exploding white dwarf can make when this process occurs. I mean, so that's a fairly healthy supply of elements. So you see, the bottom line is that these all overlap. There's an overlap within the periodic table. There's overlap for how these elements are all made within the periodic table. So I think it's pretty cool, and I just want to impress upon everybody that you're here because of these stars, and the fact that the stars have created these elements in their cores, and merged, and exploded, and died slowly. It all happens, in the universe, every bit of it. And although the universe is out to kill us every step of the way, and poses dangers to us wherever we are, it also is the provider of copious life. And I do believe that this is a populated universe. And I just want to leave you with that thought. And it's time for us to wrap up for tonight. But we will be back next week.
Right after Pine Bush.
That's right. We're going to do our Pine Bush special, folks. And it's going to be a Pine Bush wrap-up. And Amanda will be there in person. So we will talk to you then. And on behalf of Daryl and Amanda, I want to say goodnight to all of you, our wonderful KJRA listening audience. And it's been a fascinating time spent with you tonight. So remember this, folks. Keep looking up.
Except while you're driving.